Hi everyone, welcome back to the learning pathways that teach you how to build a product image search feature. Earlier in this learning pathway, you've learned how to build an object detector to let users select the object that they want to search for. So in this video, I'll show you how to connect the app that you have built with a product search backend so that the app can search for visually similar products. You can build a product search backend with your own product catalog by using the Google Cloud Vision API product search. No machine learning expertise is required. Let's learn a few concepts of the Vision API product search before we start writing code. First, each backend lives in a Google Cloud project, so we need to know the project ID to call the backend. The product search backend needs to be deployed on a Google Cloud location somewhere in the world. You'll need to choose a cloud location when you create the backend. And don't forget to take note of the location ID because we'll use it later in the app. A product set is a simple container for a group of products. A product catalog can be represented as a product set and its products. A product. After you have created a product set, you can create multiple products and add them to the product set. Reference images. They are images containing various views of your product. For example, you can add two reference images for a dress, one taken from the front and the other taken from the back. Reference images are used to search for visually similar products. Once you have created your product set and it has been indexed, you can query the product set using the Cloud Vision API. Also, it's very easy to create a product search backend by using the Vision API product search. You still need to prepare a few things in advance, such as creating a Google Cloud account with billing enabled. So to have you quickly go through the learning pathway, we have deployed a demo product search backend for you. It was built by using the Vision API product search under the hood and a product catalog of about 100 dresses and shoes. You need an API key to call the Vision API product search from a mobile app. So to keep it simple for you when using the demo backend, we have created a proxy endpoint. So what does a proxy endpoint do? When you send a product search request to the proxy, it will add the necessary authentication factors such as the API key and forward the same request to the underlying Vision API product search. Then after receiving the response from the Vision API, it will just pass the response over to the app. In the starter app, it will see the code that configures the demo backend in the product search API client class. If you build your own product search backend with Vision API product search, you will need to change the demo backend API endpoint to the Vision API endpoint, putting in your API key, project ID, location ID, and product set ID. But the rest of the code stays the same. Now, let's run the starter app. The app already has the object detection capability that you have built earlier in this learning pathway. It can detect objects in the image, show them to the user, and let the user choose which objects they want to search for. When the user taps on a detected object, the app can crop the object out and start the product search activity. Here you can see that the object has been cropped out of the original image. When you tap search, the app will call the search by image method. It will start implementing the code from here. There are two APIs I will need to call, and this is the first one. You send the query image to the backend and receive back the list of visually similar products in the product set. You need to send a post request with this body. Here's our important parameters. You need to put the query image in base 64 encoding. Specify the maximum number of results that you want to receive. Specify your product set ID. This is the one in the demo backend. The API response is a list of products in the product set that are visually similar to your query image. Let's take a closer look at the JSON response body. Inside product search results, there's a list of products that match the search query. Each product has some properties, and here are the important ones. Name is a unique identifier of the product. Product labels is a list of predefined tags of the product. They are useful if you want to filter the search result, for example, showing only women dresses. Score is the value indicating how similar the search result is to your query image. Higher values means more similarity. Image is a unique identifier of a reference image. You'll need to make another API call to get the URL of the reference image, download it, and show it in the app. So this is the second API that we should call. You only need to send a GET request. The URL path here is the same as the image field in the response of the first API. The API response contains a JSON object like this. Name is a reference image identifier, the same value that you have specified in the request. URI is a path of the image on Google Cloud Storage. Because the images on this bucket are all public, you can just replace the ZS prefix with storage.googleapis.com to download the image. So that's all the theory. Let's see the code. In the app, we have implemented all communication with the API in this product search API client class. There are two methods. This one is to call the image search API, and this one is to get the reference image URLs. We use the Valley library to make HTTP requests and use JSON library to pass a response. Besides, we use the Android task library to return the product search result to the caller, and in this case, it is the product search activity. Let's run the app. Select the object that we want to search for, and voila, here's the search result from the Vision API product search. Do you think the results are reasonable? One thing to keep in mind is that because our demo product search catalog only has about 100 products, so the backend can only try to find similar images in that 100 products. If your query image doesn't look like any of the items in the product catalog, you won't get a reasonable result. But you can try building your own product search backend using your own product catalog and see how good the result can become. Finally, if you want to try out the code that I have just walked you through, please go to the code lab following the video in the learning pathway. Thank you for watching.